我見到大家咧都見到呢條難啲咧，都唔做住嘅。我巡下房嗰陣時，我見得到你哋都唔做住嘅。咁一跳咧就跳咗去下邊嗰幾條啦。咁呢幾條，譬如第3條咧就好易嘅。咁第4條我要講，第3條 B part 要講一講，講緊呢條先。Now for the third one, I think you already encountered something similar during the assignment or something like. The main hurdle is about the 3B. Okay, but anyway, for the first part, it's talking about well, whether you know 1 feet is equal to 12 inches. OK， 1尺有12寸。OK， 都俾埋你㗎啦，你哋唔知冇所謂。OK， 咁你以後記住啦。OK。And 講開尺咁，香港計買樓啊講尺啊，大陸買樓啊講米啊。OK， 你記住，如果譬如大陸買樓，譬如100平嘅，咁即係100平方米啦嚇。計翻嘅話，你大概乘翻個10到啦 ，roughly 啦嚇，唔係準確，大概即係好似1000尺咁啦。咁你哋識同啲香港學生同內地學生，你識溝通下，大家幾大啦嚇，唔好以為人哋住100平，咁就好似好細。Okay, well, and now it's 25th, and now here we got standard deviation is 5 inches, so sigma is equal to 5, and I normalize it, mu is now equal to 48, 4 times 12. Okay, now assuming the amounts produced in different minutes are independent, so we would like to approximate the probability of the machine will produce at least 2 So let me see. Produce a length of root. Okay, the amounts independent. Approximate the probability that the machine will produce at least 20 in one. Okay, each minute, a machine produce a length of root. Okay, so in 1 minute. So in 1 minute, a machine produces a length of root of, so produce mean is equal to 48, and with standard deviation is equal to 5 inches. Okay, and now ask you in an hour. Okay, in an hour. So let's say we have xi to be the amount produced in the ith minute. So in other words, now we have x1 add up to x60. Okay, and we would like to see whether this overall, the probability that the machine will produce at least 250. Okay, 250 fit. That means times 12. Okay, and we would like to see whether this exceeds this probability. So how to find that out is pretty easy. So we just consider x bar to be equal to x1 adding up to x60 and then divided by 60 x bar. This is the x bar. And here is the probability x bar bigger than, we have 250 times 12 and then divided by 60. We would like to understand this. Okay, or in other words, we have 5 here. That means 50 at the end. Okay, so we would like to see the probability of the expected value bigger than 50. All right, and for sure we can use the central limit theorem. And we have x bar minus, so the mean is what? The mean is 48 here. 48. Okay, and then divided by the standard deviation is 5, right? Okay, 5 here. Okay. And bear in mind, you still have to divide something further. Dividing square root of 60. Okay, 我諗啲人通常錯都係漏咗呢個。Okay, and then bigger than 50 minus 48, and do the same thing here. Okay, and this candidate would become a standardized normal random variables. And then you check out the table. You got the numbers. Okay. So it's pretty standard. The only thing you have to do is to understand the questions. Okay, to pay attention on the question here, each minute produce this guy, and you are asked to find out what is the total over an hour. Okay， 得唔得？冇乜咩特別呢度。So how about this one? Now, I already emphasized the use of the central limit theorem, but some of you guys, I think, it's not that bad. I would say it's not that bad. Whenever they recognize this inequality, they think about Chebyshev inequality instead. Okay, they would like to use the Chebyshev inequality. Well, in that case, I think it's better for me to cheer them up. Okay, to cheer them up, so as to give more marks to them, even though it's not correct. Okay, I already emphasized the use of the central limit theorem, and we have a sample size n. Okay, but using Chebyshev inequalities is still encouraging. Okay, at least it's far much better than those guys dividing these two probabilities one by one. Far much better. Okay, so in that case, why don't we to be a bit more generous to cheer you guys up, right? In that case, I pay highest respect that list. Okay, so how to do in a more formal manner? So here is a random sample of size n. We don't know yet. We don't know yet. 不過我想講咧，有人係用啱咗個 central limit theorem， 呢條係做得啱，但係頭先嗰個 probability 係兩個相除，即係好 conflicting， 係同一個人嚟。OK 啊，睇改卷嗰陣時睇得到。咁啊，好明顯係佢嗰個 deal with 啲 probability， 佢一早已經係出咗好大問題。即係所以你哋要小心啲做 probability 嘅時候，得唔得 ？OK。So a random sample of size n is to be taken from a distribution from which the mean is mu, standard deviation is 3. Okay, and use central limit theorem to determine approximately the smallest value of n for which the following relation is satisfied. So here is the probabilities. We would expect to see this guy bigger than or equal to 0.95. So what we do is we would like to find out probability. We try to rescale the random variables. So we have x bar minus mu, and then divided by sigma over square root m as expected. That would be our standardized normal random variables. But by that time, for the right hand side, okay, less than 0.3. So we have less than 0.3 over sigma square root m. Okay, and we would like to keep this guy to be at least of amount 0.95. Okay, so in other words, what we see here is our standardized normal random variable z. So probability z absolute value less than this guy is 3, right? We are given. So we have root n times 0.01. Okay, 0.1. At least of magnitude 0.95. So in other words, we now know this guy is follows a standardized normal random variable. Okay, and assume that n is large enough. You have to bear in mind. So at the end of the day, after finding out the solutions, you still have to check whether your n is actually a valid candidate, whether it's large enough or not. Okay, but anyway, we just keep it move on. Try to assume it is following a central limit, it is a normal distribution in accordance to the CLT, central limit theorem. And we know that the normal distributions, if we would like to see the probability bounding in between two same numbers, okay, so this is 0.1 square root n, this is minus 0.1 square root n, in between this guy, we would like to see this probability is 0.95, okay. So in other words, each of the half here is talking about 0.25 probabilities, okay? 0.25 probability. So 2.5% each of the piece. So we have to look for these critical values. And to this end, what we have to do is to look for the textbook or your table, okay? So for me, right now I have to check through the book here again. I have to get your patient. 等一陣先啊。I have to check through the table for you, but I have to hold you a second to download the book. Okay, so here is ready. So we scroll back further down and further down. We see here is a table. Hold on, where's the table? Okay, so here's the normal table. We have to look for probability 0.25. Okay, so roughly speaking, here is the usual number, your old candidate, 0.025. So it is 1.96. 1.96. So in other words, we can just pick up this number to be 1.96, the smallest possible number. Okay, if in the case we get a bigger number here, this probability would even bigger, as these sizes would elongate. Well, we propagate out. We got larger portions of the middle part, so it would increasing. It will be increasing. So in other words, we have 25%, 1.96. So we only have to calculate root n equal 0.01 equal to 1.96. So roughly speaking, n would be equal to 19.6 square. Okay, all right. So roughly 300 something. It's far much bigger than the magic number 30. So that's why we can use the central limit theorem. And that's why this application is valid. Okay? So I think quite a number of you got this correct. Indeed. Okay, so